Good morning students. Today we are going to discuss module number 2. It is distance production. Here we are discussing about that angle impedance relay. So to discuss about the topic of an angle impedance relay, an angle impedance relay measures a component of the impedance of the transmission line at the relay location. So in case of angle impedance relay, it is also called as an ohm relay. Its characteristics on RX diagram is like a straight line which is passing through the origin, and it is inclined to the R axis at any angle. So look at the figure. In this figure here I am going to show the characteristics of an angle impedance relay, where the characteristics are inclined to the transmission line. So as we already discussed about the topic like reactance relay. Reactance relay is a particularly case of an angle impedance relay. The angle impedance relay is used in conjunction with other relays. For example, it is used to limit that area of Moore relay on the RX diagram and to make it less sensitive to power surges. A particular application angle impedance relay is called as a blinder. That means if you see the following figure, this figure shows the characteristics of an angle impedance relay, where x-axis we have taken that R axis and y-axis we have taken that reactance axis, and here the line Mn is perpendicular to the line PC. Here the line, if the characteristics lies before to the Mn line, then the relay will generate the command signal towards the circuit breaker. That means the operating characteristics of this angle impedance relay, as Z1 is the operating characteristics, as Z is the operating characteristics, and ZR is the operating characteristics. The operating characteristics left side of that Mn line, or which is the characteristics which are perpendicular to the line of Mn, or operating region of this angle impedance relay. Then the relay will sense that signal and it gives the trip signal to the circuit breaker. If the characteristics are above to this Mn line, then the relay can act as a blocking region and it acts as a backup protection. So let us discuss about that angle impedance relay with an electromechanical. Then the relay can be called as electromechanical angle impedance relay. For the electromechanical angle impedance relay, let us consider a induction cup type construction which is shown in this figure. In this cup like construction, okay, the torque produced in the electromechanical angle impedance relay, which is given by mathematically the formula, that is T is equal K1 I square minus K2 Vi cos of pi minus alpha minus K3. Here there are two types of torques. One torque is called as operating torque, where the torque expression T is equal K1 into I square, and another torque which is called as K2 into Vi cos of pi minus alpha. The torque T is equal K1 I square is called as operating torque, which is called as positive torque, which is used to produce that required torque as to open the contacts of the circuit breaker. The torque which is produced due to the actuating quantity of voltage or along with respect to the power, that is K2 into Vi cos of pi minus alpha, which is called as negative torque, which is used to renovate the circuit breaker to its original position, or after clearing the fault, a negative torque has been produced to close the contacts of the circuit breaker. And the constant K3 here, it is used due to that spring effect, or we can take that K3 value as 0 by neglecting that small spring constant. In case of an reactance relay, we know that alpha is equal 90 degrees because the maximum phase angle difference between voltage and current, we can take it as 90 degree. So again that if the phase angle between voltage and current should be 90 degrees, means there is no any flow of current and the overall power becomes to 0. So to overcome this difficulty, we are going to use that phase angle controller has to reduce that phase angle difference between voltage and current, that should be less than 90 degree, in such a way where we are adjusting that phase angle, so which is represented mathematically with a alpha. Therefore the alpha value we can take maximum it as 90 degree. Then the angle impedance, that is that pi value has been adjusted here according to our desired operation. Therefore in case of an angle impedance relay, it may have any value which governs that inclination of the characteristics with respect to the R axis. If you see this figure, here the characteristics are inclined to the operating region, that is Mn. Therefore the operating characteristics or the impedance, the angle impedance, it may be Z1 or it may be Z or it may be ZR. Then the relay will function, and the condition to operate this relay, that is whenever the torque is equal K1 I square, the torque produced here it is operating torque, which is positive torque. Whenever the torque is equal minus K2 VI cos of pi minus alpha, the torque becomes negative, and the torque which is used here it is to renovate the circuit breaker to its original position as to make that same operation after clearing the fault. Therefore the operating characteristics are inclining towards the R axis. Each and every characteristics address that operation here. Then let us discuss about that static angle impedance relay using an amplitude comparator. Then before that, here the torque, whenever torque K1 I square value is greater than K2 VI cos of pi minus alpha, the operating torque is positive. Whenever K2 VI cos of minus pi minus alpha is greater than K1 I square, then negative torque will produce. If you see about that static angle impedance relay using an amplitude comparator, here an angle impedance characteristics can be realized by comparing that two functions. One is I minus V by 2 ZR and another one is V by 2 ZR. One is with respect to current winding, another one is with respect to that voltage winding. If you see that condition to satisfy for the relay operation, that is here whenever mod of I minus V by 2 ZR value which is greater than that V by 2 ZR during the fault condition, whenever that actuating quantity current phenomenon is greater than that voltage phenomenon, or voltage quantity, current quantity is greater than that voltage quantity, during that interval the relay will function. Or otherwise, if the above equation, where if you do that LCM, then the simplified equation can become as 2I ZR minus V is greater than that of V. During this condition the relay will function. Or the above equation, if I am going to divide the entire equation with a letter called I, then the above equation can become as 2ZR minus V by I is greater than V by I. Here V by I means we can write it as Z. Then the above equation again we will write as 2ZR minus V by I and V by I. So here V by I we can write it as ZR and Z. Therefore whenever the relay will function means the relay will function whenever that 2ZR minus Z component is greater than that of mod of Z in terms of impedance or in terms of angle impedance relay, or whenever that current actuating, whenever the actuating quantity current magnitude is greater than the voltage magnitude, the relay will operates. If you see that the characteristics of an angle impedance relay, P represents at any point on the phasor. If you see here P, the P is represented here. Okay, now if you look at that, the length of the line AP, the length of the line AP is equal Z, and also that the angle impedance characteristics is represented by Mn. Mn is nothing but the characteristics of an angle impedance relay, that is, so whatever the characteristics which does this Mn line in perpendicular, those all are the operating characteristics of this angle impedance relay. Either the impedance can become as Z1 or Z or Z suffix R, but the operating characteristics are just touches that Mn line, then it generates a command signal to trip the circuit breaker. If it crosses that the characteristics of Mn line, it won't generate any command signal to trip the circuit breaker. Simply it operates that blocking region or simply act as a backup relay. The point P on the left hand side of Mn, that is PC, is greater than AP. So here the length of PC, the magnitude or the length of line PC is PC is equal to the length of the line AP, and also that 2ZR minus of Z value is equal mod of Z, and PC, if the point P lies on the right hand side of Mn, that is PC is less than AP. Whenever PC is less than AP, then 2ZR minus of Z is less than mod of Z. During that interval, the relay will not trip the circuit breaker. Whenever it is less than, whenever 2ZR minus Z is greater than mod of Z, then the relay will trip the circuit breaker. If you discuss that same angle impedance relay using as a phase angle comparator, because the phase angle diagram which has been shown in this figure 6.32a with respect to voltage, current and voltage drops, there we can understood that very clear. A line which is perpendicular to phase of ZR, the line which is perpendicular to phase of ZR, that is I into ZR minus V. This is perpendicular to ZR. Then the operating characteristics are I into ZR minus V. And similarly the angle impedance characteristics using phase comparator here, with respect to that phase comparator, the angle impedance characteristics, the angle impedance characteristics here, the theta is the angle between ZR and ZR minus Z, and the maximum value of theta here it is 90 degrees. If it is less than 90 degree, it will trip the circuit breaker. If theta is greater than 90 degree, it won't trip the circuit breaker. Therefore, tripping and blocking zones has been shown in this figure. If the point P lies in the tripping zone, then theta is less than 90 degree. If point P lies more than the 90 degree, then it won't operate that circuit breaker. Thank you.